Okay, class. So far, you have learned Z-test or normal test. Okay, so normal test or Z-test we use when we have n. Okay, our n is greater than 30. So it means for the large sample. So we use the Z-test. But today, we are going to learn something, a new distribution, which is called as t-test. And we need to use the t-test when our n is less than 30, right? So where we have small samples. Right, so what I would like you to do, I would like you to write just next to chapter 8, all right? So here at the top of chapter 8 on page 86, I would like you to write as big as you can, just write n less than 30, right? So at least you know that this chapter is actually for small n, for small sample, n less than 30. So just write as big as you can. Okay, so we are going to, our objective of learning this chapter is actually to learn how we can use, how can we perform hypothesis testing and what is actually t-test and when do we need to use t-test, right? So the assumption for the t distribution, so before this we learned the z distribution for big N, all right? Oh, okay. And today we are going to learn for the T distribution. Actually, the characteristics is almost similar to Z, right? Similar to normal. So it's just that when I can say that, all right, the normal distribution is actually the mother, right? And then the T distribution is actually the daughter or the son. So now we have n greater than 30. So for the t, we have n less than 30, small t. So this is for the t, this is for the z. But the mean here is always the same, okay? And in terms of the shape, it also, the T distribution also has bell shape and also symmetric, just like the normal distribution. And also when we convert the T, all right, so from, let's say the X form to the, before this, we convert to the Z form. And but now we need to X form, we need to convert to T. So the formula will be the same, right? So we are going to use the same formula, but it's just that we need to use whatever information from the mean sampling distribution, right? So, but the characteristic will be the same in terms of it should be randomly, the sample should be randomly selected, and then it should be normal distribution. When I say normal, it should be balanced, left and right, okay? So you can also refer to page 86 when you can see the assumption for the students' T distribution. Okay, by the way, the T distribution is also known as students' T. The student here is not for pelajar, for student like you all, but student is actually the name of the inventor or the mathematician who actually developed this T distribution. So his nickname is actually student. Okay, that's why it is called as students T distribution, right? And then if you look at the assumptions on page 86, so the sample must meet these requirements in order to make reliable inferences, okay? The sample must be randomly selected. That one is very, very important. If you, when you select your sample and then you being biased, so it means that your sample not going to be normal. It's going to be skewed, either left skewed or the right skewed. And then the next one, the population from which the sample taken must be normally distributed. So you need to understand the concept of normal. So when it says normal, so it means that at the center it will be the highest peak, and at the tail is getting, This here is increasing, here is decreasing, and normally, all right, the majority of your sample will be located at the center, right? So that's what we call it as normal distribution. Okay, so what are the differences between the z-test and the t-test? Okay, the first one, the very obvious one is actually, all right, in terms of the n. This one for n greater than 30, right? For the t-test, n less than 30, right? So the next one, okay, I'm talking about the differences. I'm not talking about the similarities. Okay, the similarities are just like before. So, which is, you already mentioned, the assumption. That one is the similarities, okay? So the second one, so we need to use this one on page. The table that we use is page 208, but somehow for the t-test, the table that we need to use on page 209. So it's slightly different. And then for the z-test, okay, we just need information x, all right? For example, sorry, we need the information mu and also sigma, right? And then if we have mean sampling, then we need also n, right? So, but for the t-test, we need more information, right? So we need the mean, the standard deviation, all right, and and there's a new one here which is called as df. So what df is actually degree of freedom, okay. So the degree of freedom, how can we calculate the degree of freedom? Is actually n minus 1. Okay, so that's the difference between the z-test and the t-test, right? So uh, we need one more information, which is called as df, or degree of freedom, right? So there's the differences. Okay, so this is the table that we use, all right, for the normal distribution or for the z distribution, page 208. But for the t, right, so we need to use a table on page 209. Right, so when you look at the page 209, again, it will be the same here, all right? So here will be 0 at the center. Again, all the probabilities below here is actually to represent the tail, okay? The tail part, right? So then you can see here, all right? Here, the is like V here is actually gamma. This one is actually for the, uh, sorry, DF, right? So that one is DF. So then this one is your alpha, right? So you can just write DF is equal to this one. Okay, so remember, the formula for the F is n minus 1. Okay, so all these are the alpha or the error or the rejection region, right? So that's what we call it as alpha. So that's the main differences between, in terms of the table, right? That we are going to use for these two distributions, right? So now let's turn to page, okay, 87. Okay, so if you can see, it will be the same, right? So the formula that we need to use, okay, for the distribution, it will be similar to the mean sampling distribution for the t-test, right? And then the test statistics, as I told you before, for in order for you to calculate the value, before we calculate the value of z, now we need to calculate the value of t, all right? Uh, T here, all right? So here, let me put it as number 4. Okay, number 4, we have Z is equal to X bar minus mu divided by sigma, sigma, okay, X bar. Or, okay, this one, sorry, shouldn't put it here, okay, right. So this is the formula for the z for the test statistic for the normal distribution. But for the t, okay, we are going to use the same formula but this time we are taking all the information from the sample. Okay, so the mean sample and also sigma for the sample, right? Okay, people, so if you need more time to write what I have written, okay, on this screen, please let me know. So I will give you a few minutes for you to write it down, okay? All right, so let's continue. Okay, thank you, Roha, for your response. Okay, thank you very much. Okay, right, so let's go to page 88, right? So page 88 is actually to describe or to explain the overview of the t-test. Okay, usually people will write it t-test, small t, right? Why t? I think, okay, is just because student, right? So the last part is t. So student or t-test, okay? All right, so t-test. This t-test is divided into two parts. We have one sample t-test and then two sample t-tests. So for the first hour, we are going to do the one sample t-test first, all right? And then hopefully on Wednesday, right? So on Wednesday, we are going to do the two samples, right? And then for the two sample t-test, so we have two types. Okay, the first one we call it as dependent sample, and the other one is independent samples. All right. So I'm going to explain it, regarding the two samples on Wednesday, right? But for today, we will focus only on the first sample and how to use SPSS for this one sample analysis. All right. So for the independent samples, so we have pool S and separate S. So again, what does it mean by pool S or separate S? So I will explain it later, right? But what I want you to do is just to write all this information on page 88 in the flow chart. Can you please do it now? I give you 2 minutes to do it.
Doctor,
Yes.
can I just confirm that the pool S and separate S falls under independent, right? Not
Yes.
dependent.
Yeah, I know. Is dia ada apa orang cakap dia terbalik kan dekat dalam
Balik.
book. Okay. Please make sure you write it correctly, copy it rightly using your brain. Okay, not don't just use your eyes. All right. Okay, it's supposed to be the two samples. The two sample, make sure which one dependent and which one is the independent part. Right. Okay, by the way, what does it mean by S here, right? So S here means standard deviation, right? So that's what it means. So at least you must know what does actually this letter means, all right? Okay, so I hope you're done with that one. So we can proceed to the next page, right? Right, again for the T table, right? So I already show it to you, the T table. So it contains, the alpha. So we know the alpha, and also right here is not Z, but it is for the T, right? So for the DF. And all the numbers here, if you can see, all the numbers here contains 3 decimal points. They are all the probabilities or the area under the curve, right? So that's the T table. Okay, so let's try to answer these questions. Okay, find the following T values using a positive. It says here a positive area with alpha equal to 0.05 and df equal to 5. Okay, so we need to look at page 209. Right, so this is how we answer this question. Okay, we know that this area, okay, this area right here, all right, should be in the positive, on the positive side, right? So we don't know the value of t, the critical value. That's what we are looking for. Okay, so we know here the alpha for this area is 0.05 and df is equal to 5. So what you need to do, just go straight to your page, to page 209, and then this is for the df. So alpha 0.05, so should be this column. And then for the row is will be 5. And then the answer should be 2.01. So this is our answer, 2.015, right? So that's all you need to do for question number part A, exercise 1A, right? So that's all. Easy kan? Very easy, amazing, right? So it's not difficult at all, right? Okay, so can you please do part B? Tolong buat part B, please. It's similar to part A. Okay, once you get the answer, you can always check your answer on page berapa ya? So, on page 108. Okay, so once you get the answer, your answer is correct, just let me know, right? Okay, so quiet. Is everybody okay? Okay, thank you, Tika. Right. Thank you, Tika, Roha, Anong. Orang yang sama je. Orang lain sibuk pergi raya kot. Okay. Alright, so let's continue. The next one. Let's do part C. Okay, part C, this time we have negative area. So the area should be on the negative side. So we have this one, okay? So at the center, always 0. And then we are looking for the negative area. So the value of t will be negative. So this part right here, the alpha is 0.01. And then the df is equal to 11. So you just go to column 0.01, all right? And then the df will be 11. So the answer will be negative 3.106. Okay, so that's all that you need to do for part C. So just make sure you don't miss the negative sign, right? So please do part D.
Sorry, doctor. I think
Yes.
for the 0.01 is 2.718.
Oh, okay.
The
Salah eh? Oh, salah
uh,
tempat eh. Okay, okay. So sorry. Okay, supposed to be this one, right? Not this one. So our answer is, I put it here, negative t is equal to negative 2.718. All right, thank you. Okay, once you finish that one, I just want you to make sure you have your calculator in front of you. Right, so as I said, we are going to do this question manually. Right, so is it page 39? 31 by 41. So this one's supposed to be 41, right? So what I want you to do, make sure you clear your the memory of your calculator, not your memory, all right? So please make sure you keep your memory on, all right? So you need to enter the data in your calculator starting from 88 and plus, 69 and plus, 141 and plus, 28 and plus, right? So I would like you to get the value of the mean, right? And also the sigma, right? So can you please get me the answer for these two values, right? Jing Chen, all right, I want you to give me the value for the x bar, right? And then I want Kaisa. Okay, Kaisa, give me the value of the standard deviation from your calculator.
Sorry, doctor. Because my calculator is left in the hostel.
Ayo, what happened to you, Jing Chen? Okay, can I have somebody else? Any volunteer? Basira, can you give me the value of the X bar? Oh, Jing Chen, what you can do? Oh, yeah. Yelah, you cakap you tak ada calculator. Alright. Basira, can you please help me with the mean value? Basira, are you there? Jangan beritahu saya hampir raya sampai tak balik-balik rumah. Tak ada, senyap je. Right. So, Tariq, are you here, Tariq? Oh, ni semua tak ada, so senyap. Ramla, are you here?
Can I answer the question?
Yeah, sure. Who's that, Mikael? Thank you, Mikael.
The
Alright.
answer is 73.75.
One.
The the mean
The mean. The mean. So you kasih jawapan yang mana ni, Mikael?
the mean
Okay, mean. Just read me the numbers. Macam like 1, 1, 3, something like that.
7 3
Okay, 7, 3.
point 75.
Okay, thank you, Mikael. Right. So how about can I get the standard deviation from the calculator? Kaisa, are you here?
Yes, doctor.
Okay, can you give me the answer?
I kind of can't consider it. Can you?
Hey, doctor.
Sorry? Can I hear you?
Excuse me, doctor. I'm Ramla.
Oh,
I'm sorry.
Ramla, okay.
I'm sorry I
No,
was
Kaisa.
calculating.
Tak,
Uh,
Kaisa. Sorry.
okay.
Ramla, sat.
Okay, doctor.
Kaisa. Kaisa, boleh tak you give me your answer first? Ramla, hold on.
I haven't got the answer yet, doctor. Sorry.
Okay, do you have a calculator with you? Yes or no?
Yes. Yes,
You,
will I
okay.
forget how to
Ramla,
do?
okay, Ramla, can you give me the answer?
My answer is 34.08.
3, okay. People, when you read me the answer, okay, just read the numbers, okay, so it will
Okay.
be clearer. 34.08.
34.08.
Okay, how about everybody? Do you agree with your friend's answer? Are they okay? Or you just simply jot it down without thinking? Okay, thank you. Who you? Okay, I believe you all who give me thumbs up that you believe them. So therefore, I also can believe them. All right. So this is the first step that you need to do, because here the question asks us to find the distribution. Right. So this is the first distribution that we need to write based on the value that we got from the calculator. Right. So we have x. Okay, sorry. X is distributed with mu and also sigma square. And then we have x, and so the mean here is 73.75. And then we have 34.08 square, right? So this is the distribution that we need to start with, right? So, right, sorry. And then we need to find the mean sampling or the T for the T distribution, because we have small n, right? So 73.7, okay, 7375, okay? So this mean will always the same, just like the mean sampling that we used to do, right? So the difference is only the standard deviation, right? So we need to find the standard error or the standard deviation for the sample. So sigma divide by square root of n. Right, people, sometimes we don't have information on the sigma, okay? Sigma is actually the information from the population. But in our case here, we only have information from small n, okay? Small sample. So usually we use the S instead of sigma, right? So actually the concept will be the same, right? So, and then we have here 34.08 divide by square root of n. So we have n here is actually 12, right? So can someone give me the answer? Isma. Isma ni macam tak ada je in our class. Okay. Hasif. Hasif, can you give me the answer? Hasif hampir mana? Duk beraya ke? Okay. Tak ada jawapan. Okay, how about Syari? Are you here? Oh, ini betul-betul cuti ni. Okay, anyone, any volunteer? Ada sesiapa yang boleh kirakan? Yes, thank you. Okay, 9.84. Thank you very much, people. 9.84. So we just put it here in our new distribution. So just make sure I always want you to box your new distribution or your answer. So that will be the answer for the distribution of this sample, small sample, right? Is everybody okay? Right. So we are going to do the SPSS, and we will check again whether SPSS will give us the same answer or not. Okay. So now let's go to exercise 5, right? So in order to answer this one, the first thing that you need to start with, always with the distribution, right? So as I told you before, as you read the question, so make sure you highlight or you circle all the information given. Okay, so we have the one, right? And then we have this one, and also this one. A meteor is specially designed to protect a lightning protection system from damage has a mean length of 39.3 centimeter and a standard deviation of 2.6 centimeter. A random sample of 15 metal rods was tested, right? So we need to find the distribution first. Okay, we start with X, all right? We have X and mu sigma square, right? So we have X and, all right, the mean is 39.3 and then the standard deviation is 2.6 square, right? So then we have n is equal to 15. So we know once we have n is equal to 15, it will fall in different category, which is the mean sampling or the t-test, all right? So, and then x bar, and remember the mean will always the same, but the difference is only the standard deviation. So for the standard error, remember when I say the standard error, it means standard deviation for sample, all right? So we have sigma or S, right? Square root of n or S, right? So this one we have the standard deviation, all right? So we have 2.6, all right? 2.6 divided by 15, right? So please get me the answer for this one. Shafa, can you get me the answer? Shafa, are you here? Tak ada juga jawapan. Okay, thank you Fakrun. 0.67. Is everybody agree? Okay. All right. So once you get the answer, just put it back, plug in the distribution here. Okay. My square, and then make sure you just box this new distribution. So it means that you are going to use this number, these values for to answer your questions, right? So once you finish this one, so we need to answer the part A only after you find the distribution, all right? So we need to construct the 90%, okay, the 90% CI. Okay, remember before this, we have the formula for the CI, X bar, okay, plus minus Z alpha divided by 2, and then sigma X bar, right? So this is our previous when we have, when we studied for the normal distribution. But for the T, it also the same, but we need to change the Z to T because we are using different table. So in our case here will be X bar, okay, plus minus T alpha divided by 2 sigma X bar, right? So these values X bar and also sigma, we can get it from the distribution we just found, right? So now the problem is we need to know, okay, for because of this alpha divided by 2, okay, so this one. So our alpha here is actually 0.1. So alpha divided by 2 is 0.005. Okay, 0.05. Okay, and then remember since we are using T distribution, so we have another value which is called as df, right? So df is n minus 1, which is 15 minus 1 will be 14, right? So later on, okay, let me do it step by step, okay? So the the x bar, we get it from here, okay? This is our x bar, and this is sigma x bar. So we just plug in the equation just now. So we have 39.3 plus minus, leave it this one first, okay? And then just put this value first, 0.67, right? And then we need to find what is actually the value for T 0.05 14, right? Here we have DF, right? So what you need to do, okay, go to page 209, right? Page 209, and then find 14, and then 0.05, okay? So this one will be the answer, 1.761, okay? Okay, so you just plug this one in, okay? 39.3 plus minus 1.761, 1.761, okay, times 0.67. Okay, so remember our answer should be in bracket. Okay, we must have lower bound and upper bound. So for the lower bound, I would like, okay, um, okay, saya it's fun cari the value of the lower bound. How can I get the lower bound? The left one minus the right side, okay? And then Nabila, okay, get me for the upper bound. How to get the upper bound? The left side plus the right side, okay? Can you please give me the answer?
The lower bound is 39. Is it
One, the
39?
39, something?
Yeah.
39 point
No, that's it. 39.
or 39, okay? All right, how about the upper bound?
40.448.
40.48. Is it like this? Betul
Yep.
ke? Okay, thank you, Nabila. All
Thank
right,
you,
how
Doctor.
about every other people? Do you agree with that one?
Doctor, for the
38
lower
point,
side, for the lower bound, the
yeah.
answer is 38.12.
Okay, so somebody just told me for the lower bound it's supposed to be 38.12.
Yeah.
How about other people? Do you agree with Roha or Iswan? So which one is the correct answer?
The 38.12.
Okay, 38.12. All right. Iswan, maybe you need to look back. Maybe you made a small mistake when typing, when entering the figures in your calculator. All right. So this is the answer. Okay. Is everybody okay? All right. So what does it mean by 90% confidence interval? So it means that this is what happened when we draft it, okay, in so the mean is 39, okay, so we already know 39.3, okay, 39.3, and then the lower bound is 38.12, and then we have the upper bound for apa tadi 40.48, okay, 40.48, right? So this area right here is actually to represent the 90% CI, all right? So it means that this area is 90%, this area is 5, this area is 5, right? So this is how it looks like in a graph. And then in your, final exam, in your test, you need to show this one, okay, as a part of your answer. Otherwise you wouldn't get, you wouldn't get you wouldn't get full mark for it, okay. Right, so let's answer part B. So it says, is the value of mu included, of mu, so miss the here, of mu is included in this interval. Okay, what is our mu? Remember, our mu always equal to the our mean x bar. So this is actually the mu, okay? So this is the mu. right? And then this is the sigma. And then random sample is 15, is the small n, right? So the mu here is 39.3. So is the value of 39.3, is it included in this lower and upper bound? Is it included or not? What's the answer? Yes or no? Yes, all right. So the answer is yes. Okay. Right, so far is everybody okay? Can you understand how actually we want to calculate the distribution of the t, and then how can we get the confidence interval for the t? Okay, good. Okay, I'm happy to see that. All right. Okay. Right. So let's continue. Right. Two ways of estimating parameters. Okay. When I say parameters here, in our case here, we are trying to estimate the x bar in order to, we calculate the, we use the x bar in order to estimate the mu. Oops. Right. Okay. So this is our job for the inferential statistic for this class. All right. So there are two ways of doing it. So to estimate the mu by using the estimation, using the estimation is we use the formula, we use the calculator in order to get the value of x bar, just like what we did before, right? And then the next one is actually to use the hypothesis testing. As I told you, this one very, very popular, especially when we use SPSS, all right? So we need to have the hypothesis. Okay, we already learned how to actually to develop hypothesis, and then how actually we can decide whether one tail or two tail, and then how can we test the hypothesis using what we are going to learn now, right? So the two sekejap ya, nak minum air. Okay, there are two procedures to make tests of hypothesis. The first one is the p-value approach. Okay, this one when we use SPSS, right? So in the SPSS, the p-value is called a significant value, or it is also known as sigval, right? So the short form for the significant value will be sigval. And the other one is use the critical value, which is we use manually, just like what we did. Okay, we use table on page 208 and also 209 in order to find the critical value of Z and the critical value for T, right? So that's what we call it as critical value. So you have done the second part, all right, the second approach. Now we are going to learn how to use the first approach, right? So this is for the manual part, right? So we have 6 steps of hypothesis testing. So, but we are not going to use this one. Instead, we are going to use these 4 steps because we are using SPSS in order to check our answers that we have used, using the critical approach just now. So what do we need to have? Okay, so the first step, you need to write, no matter what, the distribution. Okay, so we have 2 kinds of distribution. Okay, so even you use, even you use the SPSS, but you need to identify what are the values that you can use for writing this distribution. Okay, in terms of the assumptions, all right, so far we have learned 2 distribution. Either it is Z or it can be T distribution, right? So how can you identify whether you need to use Z or T? when by looking at the n. So if the n is greater than 30, so you know that analysis need to use Z. If the n is less than 30, then it means that you need to use t-test, right? But okay, in SPSS, the beauty of SPSS, it doesn't tell you whether it uses, Z or not, right? It only has t-test because, SPSS is able to identify whether your sample is large or not. If your sample actually is started with T, if your sample is more than 30, SPSS already knows that it needs to convert from T to Z, but it doesn't show you, all right, on the screen. It just tell you, okay, you just click the T test, but actually if you have more large N, SPSS will convert to you automatically, but behind the scene, right? So the next one is to state the HO and HA, right? So remember, the HO adalah is mu equal to something. HA adalah is mu not equal, greater than or less than something, right? So that is your HO and HA. And then the second one, you need to identify one or two tail tests. So all this will depend on your HA, the symbols used or the equation used in HA. And then you need to know your alpha, right? So if your alpha, if one tail, it means that your alpha no need to be divided by 2. But if your test need to tail test, it means your alpha need to divide by 2, right? So, and then what you need to do in SPSS, so you need to get the significant value, and then you need to check if, okay, your sigval less than your alpha, then you need to reject H naught, all right? So you need to make decision. If the sigval less than alpha, you need to reject your H naught, then you can make conclusion based on your question, right? So this is what you need to do, right? So it's all. Let me check. So I would like you to go to page 105, right? So page 105. Okay, so we are going to start with our SPSS after this, all right? So, but this fourth step of hypothesis testing, you can, write it somewhere. You can either write it on page 105, or you just write on a piece of paper and then staple it to page 105, right? Okay, can you please do it now? I give you 5 minutes to do it. Okay, you on? Right. Just to let you know that what we have done just now, all right, all the examples is actually, we call it as one sample t-test, right? So this is how it looks like later in our SPSS, all right? And then remember, we need to decide the one or two tail test based on our HA, right? And let's do, I will do again. Okay, let's take a break, okay, until 12, and then we continue with our SPSS. Okay, for your information, I'm using I'm using SPSS 27. 26 also can, 17 also can, 20 also can, but I think but what is actually UTM offer is 26 and 27.